Hello everyone. So today we're going to go ahead and I'm going to go ahead and show the solution for the exit ticket from yesterday. I know it was a little bit difficult for some students, and I'm going to go ahead and acknowledge that and go ahead and show some of the steps that I was able to use to go ahead and find this solution. Okay, so what I'm going to go ahead and show you guys is that, let me hide this real quick. Awesome. Alrighty, so what I want you to know is that if there's this in a factored form, this right here is your x-intercepts, and these two right here are your vertical asymptotes. So something I want you to know is that this is already in factored form. So if you want to go ahead and find them, you can go ahead and set them equal to 0. So this right here, this x plus 3, set it equal to 0. I got x equals -3. That is my x-intercept. So at x equals -3, I got something like so. Okay. Alrighty. I can see that there is a vertical asymptote in these two terms. So I'm going to go ahead and write them over here. I got x plus 2 equals 0. So x equals -2 is a vertical asymptote. And I got that x minus 4, minus 4 equals 0 is going to give me x equals 4 is another vertical asymptote. Okay, so x equals 4, 1, 2, 3, 4, so something like that, right? X equals 4 is right over here. That is x equals 4. Alrighty, the next thing that I want you to know is that x equals -2 is right over here. And that is another vertical asymptote, okay? Something that confuses us a little bit is where is exactly this y-intercept? So to find the y-intercept, we evaluate f of 0, meaning wherever we have an x, we're going to go ahead and put a 0 there and just simplify. So hopefully you're able to see we got a 3 on top, and we have a 2 times a -4, which gives us -3/8, right? Because the negative is a times is a negative. Gave us a -8 in the denominator, just brought it to the top. So -3/8. Hopefully you're able to see that's not a complete whole. That's just a negative something around here, right? And the reason for it that I know it is less than -1 and bigger than 0. I'm sorry, should it be less than 0 and bigger than -1 is because I know that -1 is the same thing as -8/8. So that's why I was able to guesstimate that. So that's where it touches the y-axis. Alrighty, let's go ahead and see if we have any holes. Well, in order for us to have a removable discontinuity, right, a hole, is that we need to see these factors display themselves on top and on the numerator and the denominator. So hopefully you're able to see that all of these factors are different both in the numerator and the denominator. So we don't have any holes, but there will be a case where we do have holes. How about horizontal asymptote? Well, that goes specifically to looking at the degree. So if you look at the polynomial in the numerator, right, this right here, what is the degree of this? Well, hopefully you're able to see that it's a degree of 1. How about the degree in the denominator? How many times does x multiply times itself? Well, we got x plus 2 times x minus 4. So there's a degree of 2 on the denominator. Okay, so hopefully you're able to see that in the denominator, it's going to be a bigger degree. So therefore, we will have a horizontal asymptote of 0. And that pretty much goes back to the idea of you have a pizza and you keep on sharing it with more and more people. Eventually, your slice that you had went from having 100% to yourself to having like something close to 0. That's what I'm trying to say. Okay, so that's going to cause a little bit of confusion, and I can see that y equals 0 is probably something that looks like this, right? Okay, so the only thing that I need you to know is that something's going to happen right there, right? Because we can have an x-intercept on a horizontal asymptote, but what I want you to know is that you can cross horizontal asymptotes. However, you cannot cross vertical asymptotes. Well, honestly, it's not that bad. What I want you to know is, just to be on the safe side, is check right here, check what's happening here and here. And we can do that with sample values. Okay, so let's go ahead and pick a sample value. Let's go ahead and see that this is x equals -2. So I'm going to pick some large number, x equals, let's say, -100, and I'm going to substitute it back into my original function. So if I evaluate f of -100, I only care, is it positive or is it negative? So go ahead and substitute that in. I don't care about the value. You can probably see that I'm going to see -100 plus 3. Well, that's still negative on the numerator. And I'm going to see in the denominator, I have -100 plus 2. That's still negative. And I have -100 minus 4. That is still negative. So at the end of the day, I got a negative over a negative times a negative, which is a positive. So at the end of the day, I can see that this right here is still a negative. Okay. Alrighty. So I want to go ahead and say that it's going to go like this, but let's just be on the safe side, because this right here, this touching the x-axis, it's concerning to me. So I'm going to go ahead and pick a value that is a little bit right here between this x equals -3, it's x equals -2. So we're going to go ahead and substitute that. Let's say for funsies, let's go ahead and decide that it's going to be -2.5. So the same thing, -2.5 plus 3, that gives me a positive on the numerator, right? I go ahead and check for my other one. If I go ahead and put a -2.5 right here, I can go ahead and see that it is still going to be negative, right? And if I do it over here, it's going to be negative. And if I go ahead and see that it's going to be positive over positive, so just like we mentioned, it actually crossed the horizontal asymptote. So it was good to check that, right? Because honestly, I wanted to do the same thing that you guys probably would have done, but notice how it touched it. So it crossed. So be very careful. These will tend to happen as it touches the x-axis, and there's an asymptote on the x-axis. Alrighty, so let's go ahead and try the next one. I'm gonna go ahead and give myself a little bit more space and pick a number to the right of 4. I don't care what number it is, as long as it's bigger than 4. So a lot of students shouted out that 500 works. And if you put 500 into the f of the function and you evaluate, is it gonna be positive or is it gonna be negative? Well, substitute it, it doesn't hurt. I know you guys can go ahead and solve it. 503 on the top, and then you got 502, and then times, what is it, 496. Hopefully you're able to see that no matter what I do, that is all positive numbers. So this is going to be positive as also. Okay, and that's just going to stay positive forever. Alrighty, so this was the exit ticket. I understand it was a little bit confusing, but all you have to do, guys, is a little bit of practice. Okay, let's go ahead and try one more. So go ahead and pause this video and go ahead and give this a try. So we can see that this right here is not factored right in the denominator, but we can go ahead and factor it probably by guess and check. And a lot of students during the live class were able to answer it. So hopefully you're able to see that this was a 3, this was a 1. And in order to go ahead and multiply them together, they gave me a 3. And in order to get a full positive 4, I went ahead and added them. So not that bad. Okay, so what I want you to know is that this right here is in factor form. They will not always give it to you factor form, but it is a nice step to have. So I'm going to go ahead and write it, x plus 1, x minus 4, and I got x plus 1 and x plus 3. Okay, this is the exact same thing. Okay, something that you should notice right off the bat is this right here, this x plus 1 and this x plus 1. Notice how it repeats itself, if you will, on the numerator and the denominator. That means you have a whole present, whole at wherever x equals. So I'm going to go ahead and say that this is an x plus 1, and set it equal to 0. So therefore, I have a whole at x equals -1. There's a whole, there's a removable discontinuity at x equals -1. And I encourage the students to go ahead and scratch this out. Since we found it, the whole, we don't no longer need to use it. So we are working with the leftovers, x minus 4 divided by x plus 3. So hopefully you're able to see that this right here is an x-intercept, and this right here is a vertical asymptote. So we can find them real quick. And as the students are mentioning in class, they like to flip the sign since it's a little bit of a shortcut, but it's going to be x minus 4 equals 0. X equals 4 is my x-intercept, or my 0, if you will. And we can find the vertical asymptote as x plus 3 equals 0, x equals negative 3. That's my vertical asymptote at x equals negative 3. So let's go ahead and graph this negative 3 vertical asymptote. I'll do it with the red. So x equals negative 3 looks like so. And I have a 0 at x equals 4. I'll do it in purple. X equals 4 is right over here, like so. Okay. Let's go ahead and find this y-intercept. So remember, you go ahead and substitute 0, right? To find the y-intercept, we substitute f of 0, right? X equals 0 into every single term. And we get to see that on the numerator, I got the 0 minus 4 divided by, divided by 0 plus 3. So negative 4/3, which is, right, it's bigger than 3 over 3. So it's going to be a little bit lower here. So just by brainstorming, we can see that probably these two are going to go ahead and connect, right? So just to using our critical thinking, we could probably see that something like this is going to happen so far, right? We don't know for sure, but this is what my brain is telling me, that for sure those two are continuous because there was no vertical asymptote between those points, right? Alrighty. The next thing we're going to go ahead and look at is the degrees of each term. So I don't mind if you look at this one, or I don't mind if you look at the leftover, but you're going to go ahead and see that the degree, right? How many times does a polynomial in the numerator multiply it to itself? So I got an x right here, and they got an x right here. So I got a degree of 2. And here we can see this one's a lot simpler, degree of 2. So because they're the same, my degree n is the same thing as degree m, I should have that they are equal to 1, right? So my degree is y equals, I'm sorry, my horizontal asymptote is at y equals 1. Let me go ahead and draw that. And notice how we are definitely starting to notice the shape right here. So this is y equals 1, and this was x equals negative 3. So another thing that I want to go ahead and point out is there's no way the graph could have went up like so, because then we would have had another x-intercept, but we don't. So therefore it went down. So the only x-intercept we had was when it crossed the x-axis, and it was at x equals 4. Okay. One thing that I want to go ahead and point out is that we have a hole at x equals negative 1. So at x equals negative 1, we have a hole right here, wherever the graph is. And if we want to be super exact, all we have to do is substitute right here, the negative 1 into this right here. So I strongly recommend that you find out the exact location, and we can go ahead and do it. Negative 1 minus 4 divided by negative 1 plus 3. So we got negative 5 divided by, what is this, 2, right? So if you struggle to look at these, just think about it. This is the same thing as saying 4 over 2 plus 1/2, which is 2 and 1/2, right? Or you can think about it in quarters. Just keep in mind it's negative. So it should be a little bit lower than what I have. It should be right over here. That's the hole. That is where the graph has discontinuity. Okay, we're almost done here. The next example, I'm sorry, this right here, we can go ahead and see that we need to find out what is going on in this section right here. So what is going on beyond this point, right? So the same thing goes, guys. We're trying to evaluate some test value. I don't really care which one you decide, as long as it's to the left of whatever this number is, the vertical asymptote, right? Which in this case is the negative 3. So a number to the left of negative 3, let's pick, I don't know, negative 1 million. So we're going to go ahead and test negative 1 million. Okay. And what I want you to see is that we only care about the sign. If the sign is positive, then it's above the x-axis, above that y equals 1. If the sign is negative, then it's below. Then it's below the y equals 1 horizontal asymptote, meaning it's negative. Okay, so let's go ahead and substitute. Again, make life easier for yourself. Substitute into this one. It's less numbers, and it should be easier, right? So negative 1 million minus 4 divided by negative 1 million plus 3. So hopefully you're able to see that negative 1 million minus 4 is still negative. I don't care what the number is. And then in the denominator, negative 1 million plus 3 is still negative. And negative divided by negative is a positive. So my graph should be above like so. So this right here is my solution. Okay. Last but not least, guys, I'm going to go ahead and talk about the domain range. I tend to forget that. So here is my domain. So my domain is pretty much telling me how far left, how far right can I go. So hopefully you're able to see that the domain is as far left as you can go, right? This is telling me as far left as I can go. So negative infinity all the way to this asymptote, so negative 3. Union, it continues at negative 3 all the way, right? All the way to this hole, which we said was at negative 1. Then from negative 1, I'm going to go ahead and do a union. And then it continues, fine and dandy, all the way to infinity. So that is your domain. So pretty much how far left, how far right does it go? Okay. Alrighty. The range, on the other hand, pretty much how low does it go? Well, this arrow is telling you from negative infinity all the way to this asymptote, which we said was 1. And then it continues from 1 all the way to infinity. So pretty cool on the way it was going, right? Awesome. Alrighty, so let's go ahead and continue. Ooh, did I forget the hole? So the hole we just said was a 2.5. So sorry about that. So instead of going to 1, it stops real quick at the hole. I just saw it right now. But I'm pretty sure you guys would have fixed me in the comments also. So it's going to be from negative infinity all the way to, what did we say it was? Negative 5 halves. Then continues at negative 5 halves with a union all the way to 1. Then from 1 to infinity. Awesome possum. Okay, let's go ahead and try this next one. X minus 1 divided by x squared minus x minus 6. So go ahead and give this one a try. So go ahead and pause the video and give this a try. So we're going to have to factor first. And we're going to go ahead and see that I need a 3 here and I need a 2 here and a negative because the bigger sign and the bigger number keeps the sign. Like so. So do we have any holes? No, right? But we do have, on the other hand, we do have zeros. We have right here, these are x-intercepts, and we have 2 vertical asymptotes. So a 0 at x equals 1, right? Because if I set this equal to 0 and I solve for it, I get x equals 1. Do I have any holes? No, I don't. Do we have any vertical asymptotes? Yes, I do. And I get each one set it equals to 0. So x minus 3 equals 0. And x plus 2 equals 0. So x equals 3 and x equals negative 2 are my vertical asymptotes. Pretty cool. Do I have any horizontal asymptotes? Well, let's look at the degree. My degree here is 1. My degree here is 2. So it's bigger in the bottom, right? So therefore, my horizontal asymptote is y equals 0. So this is very similar to the exit ticket from yesterday. But it doesn't hurt to practice some more. So we have all of this, y equals 0. And we have vertical asymptotes at x equals 3 right over here. And x equals negative 2. Okay, let's go ahead and find our y-intercept. So we find y-intercept by setting our x equal to 0, right? Because this is where x equals 0, and we're looking at the height on the y-axis. So we're going to go ahead and see 0 minus 1, 0 minus 3, and 0 plus 2. So we get negative 1 divided by negative 3 times 2 is negative 6, so positive 1/6. So something like so. That looks like 1/2. Okay, something like that. Okay, so the next thing we're going to go ahead and do is we're going to go ahead and put our values. So we have here 1/6, and we said that x equals 1. So we're going to go ahead and see that these two are for sure connected. And this is what we're going to go ahead and see for this so far. And as we did in the previous example, guys, you can test for a value and you can see that it's going to go ahead and cross a horizontal. And that's perfectly fine, guys. These asymptotes pretty much forced it to cross a horizontal instead of the verticals. Okay, so let's go ahead and practice the test values because I feel like that's what confuses students most. So we said that this is equals x equals -2. So I want a number to the left of -2. So pick a number. So f of, I don't know, -777, sure. And you substitute it into your function, right? So I got negative 777 minus 1. Guess what, guys? That's still negative. I don't care what number it is. And then in the denominator, we have negative, right? Because negative 777 minus 3 is still negative. And let's say I add 2, that's still negative. So all of this is a negative over a positive, which is still a negative. So all of this is negative. Okay. Alrighty. The next thing that we're going to go ahead and do is find what's happening to the right of x equals 3. So pick a value. Sure, it could be as small as 4 and evaluate that. And I just pick bigger numbers just to teach you guys like, hey, you don't care about the value, you just care about positive or negative. So go ahead and try that. Is it positive or is it negative? Okay. So substitute, I got 4 minus 1 divided by 4 minus 3 and 4 plus 2. Okay, so I go ahead and solve. I see that 4 minus 1 is 3, but that's a positive to me. And in the denominator, I got 4 minus 3. That is 1. That is positive. And 4 plus 2 is positive. So all of this is positive. So it has to be like so. Pretty cool, right? Okay, that's all I have for you guys. Oh, and a little meme for us. You know, the graph past the horizontal, and well, now we're gonna head out, right? But keep in mind, just with practice, it gets easier. So I give you guys 3 practice examples. I do want to see what you guys have on Friday on your digital notebooks. So as you can see, you will have to factor first on mostly all of them, but they're not that bad, right? Alrighty. The exit ticket for today is right here. It's already uploaded. So go ahead and give this one a try, and we will talk about tomorrow on what we were able to obtain. Okay. All right, guys. As always, it was a pleasure. And if you have any questions, you can go ahead and meet me in tutorials today at 5:15. Okay. Thank you. Bye-bye.